everyone. So today I'll be discussing question number 31 of GATE 2014 set 1. For the cantilever beam of span 3 meter, a concentrated load of 20 kilonewton is applied at the free end, causes a vertical displacement of 2 mm at a section located at a distance of 1 meter from the fixed end. If the concentrated vertical downward load of 10 kilonewton is applied at a section located at 1 meter from the fixed end, the maximum vertical displacement in the same beam in mm is. So it's a fill in the blank type of question of 2 marks. For this type of problems, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. Let's start with the solution of this problem. So basically in this question, they have given us one cantilever beam in which a 20 kilonewton load is applied at the free end. Okay, so because of this 20 kilonewton load, this beam will deflect like this. So here at a distance of 1 meter from the fixed end, at this section, they are saying that this displacement is, let's say it is 2 mm. Okay, now they have given us one more case. So here also the same cantilever beam we have, but here they are telling us to apply 10 kilonewton load at the same section, that is 1 meter from the fixed end. So in this case the beam will deflect like this. Okay, so they are asking what will be the maximum vertical displacement in the second case. So in this, let's say it is case 1 and this is case 2. So they are asking what will be the maximum vertical displacement for the second case. So for this case, the maximum vertical displacement will be at the free end, that is, let's call it as delta 2. Okay, so basically they are asking us the value of this delta 2. This problem is directly based on the Bette's theorem. So Bette's theorem says that the virtual work done by P system of forces in going through the deformation of Q system of forces is equal to the virtual work done by Q system of forces in going through the deformation of P system of forces. So what does it actually mean? So for example, if we have two system of forces, let's call it a P system of force and this, let's call this a Q system of force. So here we have this simply supported beam in both the cases. So we are calling this system, the first system, as P system of forces because I'll apply P load here, and let's call it as Q system of forces. Okay, so for this first system I have applied this load P here, and I could apply P1, P2, but let's for simplicity let's call it P only. And at the second system I'll apply a load here and Q. Okay, so let's call this position 1, position 2, let's call this position 3 and position 4. 1, 2, 3 and 4. Now because of this P loading, this simply supported beam will deflect like this, and because of this Q loading, this beam will deflect like this. So let's call the deflection at this point, that is 3 point, be delta 3, and this 2 point here is, let's call it as delta 2. Now Bette's theorem says that the virtual work done by P system of forces in going through deformation caused by Q system of forces. The virtual work will be done by P system of forces will be P multiplied by the deformation at that particular location due to this Q system of forces, which is delta 2, will be equal to the virtual work done by Q system of forces in going through deformation caused by P system of forces. For example, here there's a Q system of force and the deformation caused by P system of force at the same location, that is at 3, because we have applied Q at 3, so deformation at 3. So it will be equal to delta 3. So this is the statement for the Betti's theorem. So this theorem we can directly apply into our case and we'll get the solution. For example, this is our case 1. Okay, so the second case they gave us is this. So we have the same beam and we have this applied load 10 kilonewton at the same location, because of which the reflection will be there. So let's call it as delta 1 and let's call it as delta 2. So if we apply the same theorem here, so it will be 20 multiplied by, so the load from the first system multiplied by the deformation in the second system at the same location, which is delta 2, will be equal to load in the second system, which is 10, and displacement in the first system at the same location, which is delta 1. So 10 multiplied by delta 1. Okay, so the value of delta 2 we need to find out. Delta 1 is already given to us. So delta 2 will be equal to 10 multiplied by delta 1 divided by 20. So delta 1 value is given as 2 mm. So 10 multiplied by 2 divided by 20. So from here we get the value of delta 2 as 1 mm. So they asked us the value of maximum vertical displacement in the second case, and we get our value as 1 mm here.